too embarrassed by the fact that I'm down in the corner there. Okay, so we talked about this thing called a significance test. And basically, in a significance test, we're just trying to decide if there's a significant difference between what our sample is showing and what we believe to be true. Okay? Is the what we calculated from our sample significant enough to make us question our initial assumption? We have a starting assumption or a starting hypothesis and an alternate hypothesis. So the first thing we do in doing a significance test is generate our hypotheses, our H sub 0 and our H sub A. Okay, and our H sub 0 is kind of the original or the normal belief, where A is an alternate, and usually because of something that happened in our sample. Right? So reading this problem, a news report claims that 75% of restaurant employees feel work stress has a negative impact on their personal lives. A manager for a chain wonders if that's true for their employees. He takes a sample of 100 employees, 68% say yes, work stress does have a negative impact. Is that enough evidence? Is that convincing enough out of 5%, alpha equals 5%, to make us think that the proportion of all employees is actually really less than 75%? So our original assumption is that the percent of people that feel stressed is 75%, whereas the alternate option is that is less than 75%. Okay? Probably based on the fact that when we looked at the information from the sample, we got a 68%. And so the question is the 68% different enough from 75% to convince us that the actual percent is less than 75? We did get less than 75 in this sample, but is it small enough? Is there enough of a gap for us to think, oh yeah, it's probably weird, it's probably something else, or is this just normal variation? Okay. So number one, we write our hypothesis. Our original hypothesis is that P equals something. Our secondary hypothesis is that P is either bigger or smaller than, at least that's what we're doing. There's a third way to do this where P is not equal to a particular number. Okay. I think we're not doing that one today. We're just gonna do another less than. Okay. All right, so number one, we've come up with our hypotheses. Number two, we collect everything we need for our original formula. We need P sub 0, P hat, and N values. Now, P sub 0 is just the original percent, or the original statistic. So we think the original value, or the believed value, is 75%. The P hat from the sample is 68%, and our sample was 100. And we've got a big old formula that we're going to use with these three numbers to calculate something called Z, a standard tested statistic. And then we're going to think about that Z in a normal distribution to come up with a probability. So making our hypothesis is step one. We always have, we're equal to something, or we're, at least what we're doing right now, is it greater than or less than that certain number? We pull our values that we need, p sub 0, p hat, which comes from the sample, and n. And then step 3, we're going to calculate a z value. Now we've got a formula that you don't have to memorize, you just have to know how to use it. To get our z value, we're going to take our p hat minus our p sub 0, all divided by the square root of our p sub 0 times 1 minus our p sub 0, all divided by n. So we've got a big fraction under a root in the denominator, and then just a really easy subtraction problem in the numerator. Numerator, super easy to do. Denominator, we've got to do a little bit more work to get that. And I'm just going to do this. So here we go. So 0.68 minus 0.75 over big square root, 0.75, 0.25 over 100. It makes sense that we're going to get a negative number because we are doing a less than problem. Okay, so the fact that we're looking at this being in our, you're like, well, what do you mean we're doing a less than problem? I mean that as we look at our, let's grab this. I got everything all cuckoo pantsed around here. Hang on a second. Choop, choop, choop. Move that up there. There we go. All right. A less than problem. We think we're going less, the true value is less than what they stated. So a less than problem means we're probably going to be looking at something on the left side of the normal curve. Okay. And so when we create our normal curve, our z number is probably going to be over here on the left and negative. So the fact that it's a negative 0.07 in the numerator makes a lot of sense. Right, now let's build that denominator. Big square root. Fraction under the square root makes it easy. 0.75, 0.25. Oops, what am I doing wrong? Oh, because I didn't fill in the 100 yet. Over 0.0433. 7 divided by 0.0433 is about negative 1.6166, and so on. That's our z. That's over here to the left of 0. We want that area. That area is going to represent the probability that we got this answer in the context of our problem. What's the probability I would have gotten a 68% instead of a 75%? If it's a high enough probability, then we say, okay, yeah, this is nothing special. We're not going to reject the original claim. There's not really enough evidence to say the original claim doesn't make sense. If our probability is so low that it's so low and so weird that we got a number like this compared to 75, then we'd go, yeah, maybe I'm going to reject the original claim. There might be some evidence that the actual percent is smaller. So it all comes down to what this area is compared to a probability for us of 0.05. Because that's given in the problem as our test probability, our significance level. All right, so here's the part. I'm going to record this on the calculator. So you'll have this so you can remember how to do it. So here's my calculator. If I do second and vars, I get my distributions. I go to my normal cumulative distribution. I want a super low area. So a super low number up to, it's not wanting me to do it, up to that negative 6.166 number. Negative 1.6166. Select, select, select. Enter. Ooh, this one's close. I call this area big P in my notes when I write these problems. And so my big P, if I keep more than 2 decimal places, which I should, I got to be exact, it's 0.053. So big P, which is the area, is 0.053. Calculate Z, step 4. Get that capital P, or that area, from the calculator. And now, we make our comparison. Compare P and little alpha. So P was 0.053. Little alpha, we agreed was going to be 0.05. P is bigger. It's just a little bit bigger, but it's bigger. Therefore, we do not reject the null hypothesis. Remember, we either reject it or we don't. We never accept it, which means there's evidence. There's a little bit of evidence. There's some evidence that true percentage of, what were these? These were like stressed employees. Maybe, and here's careful, it's not that we proved it's 68. It may be less than 75%. It's what HA says. HA doesn't say that the percentage is any certain value. H sub A just says, I think it's less. All right. So because, there's not evidence. I'm sorry. I'm so horrible. I did that totally backwards. Let's try that again. We're going to say if we're not rejecting, then there's not enough evidence. There's not really evidence. Is less than 75. Sorry. I totally lost. I was so excited to be done, I went mental. Okay. We don't reject, there's not evidence. We do reject, there is evidence. It's kind of easy if you think about it that way. It's either you're not going to reject because there's not enough evidence. We're not going to reject HO, there's not evidence for HA, or we are going to reject H sub O, there is evidence for H sub A. Okay, so it's either not and not, or is yes and yes. So 68% is kind of on the borderline, but but in terms of the threshold we set, it's not weird enough. It's not a weird. The probability of us getting that is still bigger than 5%, which means it could just happen by chance. Okay? It's nothing special that happened. All right, so I wanted to make sure we go through more problem today. We had 2 problems yesterday, and I'll upload the notes for those 2 problems from yesterday and the one we just did for today. I am not going to be here Friday, and what you're going to do on Friday is you're going to do 3 things on Friday. Number 1 thing you're going to do on Friday is you're going to do another stat of the day. Right? It's already in there. It's about how much money people spend on promposals. Okay? So if you want to write it up now, you can. So the slide's in there. So you'll do your stat of the day on Friday. The second thing you'll do on Friday is I have 3 practice problems for you to do with significance tests. Okay? And you'll be able to watch this video if you need help doing those. And then after you finish doing your significance test work, whatever time is left, you'll be able to use to work on your project. I won't be here to help you with anything with your project, but that doesn't mean you can't try to get something accomplished. So let me stop this recording.